Hi guys, welcome back to the channel. I'm your girl Sabrina, and on this channel we talk about personal growth, university life, and all things educational, especially AutoCAD. Now in the last video, which was like 3 weeks ago, my apologies. What's going on with the dress? Yes, 3 weeks ago, I promised you that you'll be getting different shapes for oblique projection. So what I'm going to do, I'm just going to do all the shapes, all the different isometric drawings, and just post all the videos as soon as possible. And you can go and watch those. If you missed the last videos, you can go and also watch those. I will have the link down in the description below. Please stay tuned. If you learned something from this video, comment down below. If you have any questions, comment down below. If you have any requests for any other video, please comment down below. Thanks again for sticking by me. Thanks for watching, even though I'm a slack off. Thank you guys so much. Have a blessed week. So here we have our joint space, and we have our isometric joint that we'll be using as a model to complete our oblique projection. So in the previous videos, I started with the Cavalier projection, but in this video, we're going to start with the cabinet projection. Cabinet, remember the difference between cabinet and Cavalier is that the cabinet is actually half of the isometric joint size when we're going to the 45-degree angle, which you will see in this video, and the Cavalier joint is when we go the full length of the line. So let's just begin. Again, we always start with the face of the oblique. When you're doing oblique, we start with the face of the isometric projection. So the face shape that you see right here, I'm going to see if I can try and highlight it. So this entire space that you see right here, the face of it, that's what we're going to start with. So let's go. So we're going to start at the extreme left, which would be 30 millimeters. And how do we know that that is 30 millimeters? Even though it doesn't give us the full length, we can see here the space right here is 20 millimeters, and the space at the top right here is 10 millimeters. So what we'll do is just add the 30 and the 10 to get the full length, and that would the 20 and the 10, sorry, to get the full length, and that would be 30 millimeters. So we can go ahead, go down, and select 30. Enter. So this would be 30. Let me escape and show you. This would be our 30 line. Let me see if the line weight is on. So we're now going to go ahead and we can just continue. Just follow the front face of the joint and you will have measurements. If you don't have measurements, I think measurements are easy enough to figure out because we just have to do some math sometimes. But we have the measurement that this section going out here is 10 millimeters. So we have 10 millimeters, then we're going to go upwards, which would be 20 millimeters as we discussed earlier. And then we're going to go across. Now, for example, when I said we just need to do some math for some of these measurements, we can see here that an entire length going across, or the width rather, going across is 65 millimeters, and we have 10 millimeters on both sides, which would be 20 millimeters. So all we have to do is take away 20 millimeters from the 65 millimeters, which would leave us with 45 millimeters. Am I right, or am I right? All right, so let's just continue. Line, going across 45 millimeters, going down 20, cross again 10, and going up 30. Right, so far so good. Now it tells us that on the left side, this line right here, which I'm highlighting, would be 20 millimeters. It also means that the next side over here is 20 because they are equal. Again, if we would do some math, we know that the full width of the shape is 65. If over here is 20 and this section at the top is 25, we just have to add that and get 45 and just minus it from 65, which would give us 20. Hopefully you guys understood what I did there. So let's just continue. So 20 millimeters. We're going up 5 because that's what it tells us, right? This 5 right here, follow my cursor, my arrow. This 5, that is for the small vertical section right there. Going across would be 25, down 5. And then we can just go ahead and connect. If you realize that it's not connecting perfectly, then something is wrong with your measurements. As I said, in oblique projection, we should only have 180-degree lines, 90 or 45. Yes? Alright, so now we can go ahead and get our 45-degree lines, which would be 60 millimeters. Let's just pause and come back. Okay, so now we have our face. Remember that we said that we're going to start with cabinet. Cabinet is always half the lines, the 45-degree lines. So on this drawing, we see that the 45-degree line, which is going in this direction, let me try and highlight it, would be 60. Now in cabinet, half of 60 would be 30. So the lines that are at 45 degree would now be 30 millimeters instead of 60 millimeters. Let's do this. So go down to the bottom, follow my cursor. We're going to go down to the bottom and we're going to hover over this clock till we see it pops up. It's called polar tracking. What we're going to do, if it is not on, we can just go to the drop down and select whatever angle you would want, and we need 45-degree angle. It's already on that and it's already on. If yours is not on, go ahead and turn it on. So go back to line. We're going to go right here and we can just play around and move around with our cursor. So we're going to slowly move it, and you can see that it's going to stop or pause when you reach a certain point, and that would just tell you that okay, that's your 45-degree line, right? So what we're going to do is just insert the length, which would be 30 millimeters, enter. Right, now since we realize that all these lines are going in the same direction, we don't have to draw it again. All we can do is copy this, copy it, sorry, CO, copy. That's the shortcut for copy, so CO, copy, instead of typing out the entire word. So to every point that you see on the drawing in the image, you can just go ahead and copy this line. And trim wherever you see trimming is needed, for example, right here. And the shortcut for trim is TRI. Sorry, TR, not TRI, TR. And we're just going to trim. So if you realize, we now have this section at the bottom. All we have to do is connect the ones at the top. So L, enter, which is a shortcut for line, enter. Now, if you realize that your line is now scattered everywhere, it's going in whatever direction it wants. What you must do is just go back at the bottom and turn on auto mode, which would allow you to have clean straight lines. Because remember, if you are not connected with either a 90-degree or 180-degree line, something is wrong. So straight line going up, straight line going across, going up again. Now for the line on your extreme right, which would be right here, you're seeing right here, connecting to close the object, you realize it is not connecting with the endpoint. Okay? It's just a horizontal line. So if you don't want to make any mistake at all, what you can do is just copy one of these perfect lines, these perfect horizontal lines. So just copy it at one end and move it to oh, right. So we just move it here and then we're just going to trim the excess. And that is your cabinet projection. I'm just going to put some music over the Cavalier projection because it's the same thing. The only difference is you're doing it at full length. So stay tuned. But if you have a good understanding and you would like to exit the video now, you can do so. Not forcing you to stay, but if you want to see more, then you are free to stay and watch to the end. Thank you so much for watching this video, guys.